What if I want this lecture just to be for you guys? All right, let me know when we're live, Avery. All right, thank you, sir. So, as we had stated previously, we're going to be learning cloud computing from pretty much this definitional standpoint. As with most aspects with regards to the A+, we're laying these foundational bricks, this knowledge that you can kind of build upon it and use it to pursue into, you know, any aspect of IT, which there are so many pathways depending on your interests and where they take you. And as we often say, if you want to be successful in IT, be interested in IT, because you will always, always find time to learn about the things you're interested in. So our focus for this afternoon is going to be technical session number 23, learning about the cloud. And for those of you who may not be aware, there is no cloud. It's just somebody else's computer. All right, objectives for this particular technical session that we'll be going over are going to be to define the cloud and describe its purpose and what it allows us to do. Explain how IT professionals might use knowledge of the cloud to support clients with different organizations. Describe the difference between the various cloud service models, including SaaS, PaaS, and IaaS. Also, contrast the different cloud architectures, including private, public, hybrid, and community. And explain the role of security when it comes to storing information in the cloud. Hint, hint, it's not secure. All right. Behavior skills and mindsets we want to take into account when working through this technical session. Adaptability. Things are ever changing in the IT world, and we always want to rise to meet that challenge. We want to continually arm ourselves with as much education and knowledge as we can possibly get within our respective fields so that we can be better fit to undertake whatever tasks are required of us within our scope. Also, personal responsibility comes up quite a lot. If you're going to say you're going to do something, do it. Know that the actions that you have right now, that time that many of you I know are putting into studying, some of you out there, not so much, but you know, those conversations will happen. That hard work that you put in now will pay dividends. That's that personal responsibility. It's understanding that I'm making those short-term sacrifices now so that I can see greater benefit down the road. I don't want to look back later and say, you know what? I probably could have spent a little bit more time paying attention. I probably could have done a little bit more lab work, things like that. And then when we get out into the work field, if we make a mistake, own that mistake. There are a lot of times when you have a conflict with the manager that if you simply own the mistake right up front, say, yep, that was me, I made that mistake. Here is what I would do going forward to correct that. You can completely diffuse that situation right then and there. It will go no further. You can't do that repeatedly, but you know, mistakes do happen. You own it up, you own up to it. And even though that mistake was made, a lot of times you'll walk away at least with the, you know, your supervisor's respect at that point. But it's not all doom and gloom. Take personal responsibility for the good stuff too, because you are your best advocate. You are your best professional cheerleader, so to speak. And make them recognize. First, kind of start to define things here. What exactly is the cloud? Rachel, can you please bring that voiceover voice of yours, please, and read the definition of cloud for us?
Cloud computing is a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources. Example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction.
Thank you so much. So essentially, shared pool of resources, able to deploy resources as needed on demand. An amazing thing, to say the least. The cloud is essentially cheaper than you owning that entire infrastructure yourself. If we're going to be running a streaming service, if we're going to be running, web servers, all that kind of stuff, two things can happen. One, it's extremely expensive to set it up. Also, if your business model changes, it's very difficult to adjust your infrastructure quickly to handle any changes in business, especially right now. We're talking extremely long wait times for any kind of computing equipment at this point due to chip delays, supply chains, all kinds of fun stuff going on. There could be a wait of up to 6 months to a year for more networking equipment, depending on what you need. Now, your business isn't necessarily going to wait for that. If you delay your customers too much, they're going to go looking somewhere else. So we need other options. Those options, for the most part, reside in the cloud. Now, it provides a lot of answers for doing more business at a lower cost. The risks come into your security. When you're dealing with public clouds and things like that, you never, ever leave security up to the provider. That is your responsibility. You always create backups of your data, regardless. And you are going to test these backups to verify their viability as well. Windows itself has built-in cloud storage, as does Google Drive. As we're familiar with Google Drive, you have OneDrive, and then we have iCloud with Apple. So there are alternatives for personal use as well. Now, there are many ways we can use the cloud to support organizations. It is a cost-effective hybrid infrastructure you can create to pool less critical pieces of your business in the cloud, keep the more proprietary business critical stuff internally. It will helping somebody design a hybrid of legacy infrastructure and cloud computing can help create that symbiosis, I guess, to where you can expand the business more, but still maintain the security of your company. You got to help. If you're helping a company initiate this, you have to help write a cloud-based policy. What is allowed to be on the cloud? What is not allowed to be on the cloud? Who are we going to use? What are our requirements for these clouds? Because there are more companies out there outside of AWS. If you actually care about your business being online, I would suggest somebody other than AWS. Recommending different cloud programs for an organization's needs. So it's not a one size fit all. It has many different flavors and capabilities. So there are essentially 3 cloudware service models we need to be aware of. We briefly mentioned this earlier this morning. These are the 3 ones that we're going to mostly pay attention to. There are others out there, but they are beyond the scope of the course. If you get into network and security, you start talking about more of them. These are the 3 key ones we have. First you have is infrastructure as a service, or IaaS. This is essentially bare metal. This is just hardware. There's nothing else provided. It's just like, here's your servers, here's everything you need. All the hardware is set up. You're responsible for everything after that. You have to add all the software, all the applications, everything will be built on there by you, and you will maintain that software. Avery's far more trusting of the cloud than I am. But then again, he's also a much more hopeful individual than I am. I'll give him a year of studying security, then we'll talk again.
Hey, I've heard rumors about clouds, and none of it is good.
Yeah.
Some
So
of these celebs, they'll tell you.
oh yeah. So there are issues with them, that's for sure. Platform as a service. Well, let's skip over that one for right now. You have software as a service. That is everything included in one. I will get to you in just 1 second, Cynthia. So it's everything in one. It's all packaged, pre-made, set up, served to you on a platter. This would be like Gmail, Outlook. All of this stuff is already packaged, made, and we just kind of, you're getting the finished component of it. So that is software as a service. They simply just maintain all the applications, software, hardware in data centers, and you get access based off of what subscriptions you have, be it free or premium paywall stuff. Now, platform as a service. This is the middle ground. This is where a lot of people get confused. It provides that hardware as a platform and the basic software for running on that platform. Gives you the operating system and basic infrastructure software. And then the company is still kind of involved in maintaining the system. But for the most part, this is for developers. This is where you will be developing the applications. So you get the basics with this one, nothing fancy. And then you would be assisting in developing the applications and stuff like that. So software developers, stuff like that, this is where they would typically thrive. Do you still have a question, Cynthia, or did I inadvertently answer it?
Well, you kind of sort of did, but I would rather you just finish all three models and then I'll reframe the question.
Okay. So whenever you hear development of applications, always go to platform. That's your middle ground. Software as a service, complete product. Everything's already done for you, already packaged with a nice, neat little bow and handed to you. Infrastructure as a service is bare metal. You do everything except maintain the hardware. They do that. That's the three main models. So, questions, Cynthia?
So I just want to make sure I understand all these three models because I know it's going to be important for me down the road. So the first one, the web provider, like if you're just like a software engineer and let's say like Google say, hey, can you create a software for my hardware infrastructure, and I'm creating something for security purposes. Me as a developer and let's say a cloud engineer, specialist security, right? I would basically be in between the platform and the software to help the infrastructure on the hardware part.
No, you would be straight in platform because you would be developing systems to use somewhere else.
Okay.
So that would be firmly in platform. You're developing and scripting and writing systems and stuff like that and developing applications. You would be firmly in platform as a service.
Okay. And so the hardware is just for the ISP people, like they're the ones.
Well, hardware would be like, you have homegrown systems and stuff like that that you've developed over time. Like your company's been around a while. You basically hired people out to create your own systems. And you would rather run on that than what they have, but you just need the metal to run it on, or the servers or whatever. Right. Then, you could do the infrastructure as a service. It gives you all the servers, everything you need. And then you can just upload your own software and maintain your own software in the servers, especially if it's something like you just need extra web servers or whatever, because you've got, spiking customer demand around the holidays. So you need to, like, if 80% of your business is done between November and January 1st, you don't need all those servers for the rest of the year. You only need it for those 3 months. So you buy that infrastructure for those 3 months, you duplicate everything you have over to it, and you maintain it the way you need to. Then when January 1st comes, you shut down those servers, you go back to your normal operations. Then software is just kind of like a package deal. Everything's already there for you, and you're just kind of up and running.
Cool.
Yes,
So
Glean.
like, oh, sorry.
Oh, sorry, finish. Go ahead, Cynthia.
So the software would just be like if I put out a version, like a beta version, I'm constantly like upgrading, almost like the hot. Was it like the hot? If I'm using the right term, the service packages. Like Windows has its service packages where it handles all the updates and fixes.
Kind of, but the
Kinda.
software as a service is like the finished product, like everything's already done. That's Microsoft Office, it's Word, it's all that stuff. When you're doing these subscription services on the cloud, then, that's software as a service. Google, Gmail, all that is a software as a service.
Got it. Okay.
So,
all right, cool. Thank you.
when you're talking about beta, you're getting into that fuzzy line where you're still talking about application development and stuff like that, which would put you more in platform.
Okay.
Yes, Glean.
I was kind of, in a way, trying to piggyback off of that because I wanted to say a slightly stronger definition in terms of the three. So software as a service would be like, say, Google or Bing or any of the apps of which we would use on our phones if it goes into a cloud. And then this way, it kinds of being interactive in that sense.
Yes.
A platform is where, like, say, if I was a developer and I was making an application, but all the other pieces were there.
Yes.
Never free. All right. So then the last one would be like I had to build the phone and make the application and make the feature that comes in.
No, you don't need to build the phone. The phone's there, but there's just nothing on the phone. There's no operating system for you to start with.
Okay.
They're just like, here's a phone.
Right. Okay.
So that like they give you the actual physical piece of equipment. Everything else after that is on you. There is nothing on it. Basically, it's like me handing you a desktop and the only thing that's on there is the motherboard's BIOS. That's it.
Right. Okay. Then now that makes okay. That's because I was like, where are we going to? So all right. Thank you.
So it's literally, like you turn it on and then everything else you need to add. So that's infrastructure. So infrastructure is just that. It is just the physical components, everything else you bring to the table. Software is complete package. Everything's already done for you. Platform, developer's playground. You're making the applications and developing software. Questions? All right. Types of clouds. I'd like to focus on these four. Yes, Steve.
Yeah, what is it called when you use a cloud through the web? Because you know how the other day we copied something for a network, and I couldn't find it on my downloads. I had to go online to find that thing that we copied.
Well, it's essentially what you were using is basically you were sending something from, one part of the cloud to another part of the cloud, but it's still cloud computing. But you hadn't brought it down from the cloud to your device. You just basically transferred it from one portion of the cloud to another portion of the cloud. So, all right. Types of clouds, 4 main types of clouds. Basically, depending on how you're going to be using it, you will implement one of these models. First is the public cloud. This is your Google Drives, your iClouds, stuff like that, AWS. This is a third-party operator that you are renting a service from. And you're utilizing their equipment to supplement your needs. So this would be considered a public cloud. It puts your data essentially in the hands of that third party. But in theory, they're supposedly more capable and knowledgeable about protecting data in this environment than your organization. The other side of that coin is a private cloud. This is one that your organization maintains itself and allows employees access to. This is where you would store mission critical stuff, research and development, you know, personally identifiable information, medical information, stuff like that. This would be maintained more in a private cloud rather than a public cloud because of data security issues. So if you have highly, highly sensitive data, you don't put it in the hands of a third party, you maintain it yourself. Then there's hybrid, which is predominantly what most organizations do. If they're utilizing something like this, they will have a portion of their servers held privately, which would be their most sensitive mission critical information and data. That would be held within the organization on the private cloud. And then they would use the public cloud for less sensitive stuff, sales data, websites, fun stuff like that. So that would be the hybrid model, which is a blending of the public and the private. And then finally, we get down to community, which would be multiple organizations who are working towards similar goals would essentially create a common cloud. This happens a lot between universities working on common research projects, companies with shared particular mission statements. They may have particular things that they're trying to develop together, but they don't want to merge the entire company. They'll have essentially what's called a memorandum of understanding, which is an agreement between these two organizations. They'll create a cloud where they will store that communal research. So it is a community cloud. Typically think of universities when you think of this, multiple universities working together on common research projects. All right. Features of the cloud itself, things that we would identify specifically with third-party public cloud providers. One is considered rapid elasticity. And this is the capability to scale to cope with demand as it peaks or, wanes. This also includes your CPU and memory in those cloud devices. So if you make t-shirts for a living, and then some Hollywood star is seen wearing your shirt, everybody wants to buy that shirt, so all of a sudden your demand spikes 10,000%. You can go expand your website's capabilities through rapid elasticity to handle that demand, and 2 weeks later, when everybody forgets about that t-shirt, you can scale it back down to normal life. You don't have to invest in a whole bunch of infrastructure just to handle that short-term spike. You can use rapid elasticity and pay for what you need. On-demand self-service. The customer themselves pay for what they use. So it can be scaled up or down as your needs change, but you're only paying for what is used. And on-demand basically means there is no other intervention needed. You can go in and scale it as you need to. So you don't need to talk to a rep. You don't need to get permission. You can go in and just scale things up as you need it. It's on demand. Next, resource pooling. You can store these resources. They can be pooled across multiple customers rather than each individual trying to set up their own clouds. They're essentially, everybody's paying in to create this very large infrastructure that is maintained by a third party. And then there's measured billing, where it's kind of like your electricity. Billing is metered and delivered as a utility service. This month you used X amount of hours. Last month you used, 15% less. It's metered service or measured service, excuse me. Yes, Susan.
How is measured service different from self-service? Is it just because measured service, you just like have a plan and you don't have the capability of adding or subtracting
Well,
from it?
No, measured services basically it's just that it's the, you know, odometer. It's clocking up how much time you're using. And then at the end of the month, however much time is on that clock, they give it to you. Where on-demand service is more, you know, hey, I'm seeing a spike today. I need to go in and activate more resources. My demand's less tomorrow. I can go in and grab those resources and scale them down.
Okay.
So on demand is your ability to make those fluctuations. Measured is essentially the meter to which it is being, you know, you're being billed for. And then rapid elasticity is the ability to change the size of that really quickly. Rather than saying, you know, like I need more, you know, I need to ask for more services for a month from now, rather than I need it, you know, in 30 seconds. Is there any spy program in the metered power clock? Possible. I can't think of one off the top of my head, Dermis. All right. IAS or HAAS. Company has more control, in charge of securing operating systems and server, because you control everything. You're not relying upon excuse me, you're not relying upon them for anything except the bare metal. So that's all you're essentially worried about. So it is more secure than the others. PAS, no direct control of the data, people, or the infrastructure itself. Trained security professionals are watching all the data. So again, you have third parties watching over the data itself. You are not necessarily in direct control of it, but you're predominantly using it for development and applications. Yes, Cynthia.
I have a question, is because test out is an emulator, right? For like, you know, to simulate.
Test out is a simulator, not an emulator.
So a simulator, not an emulator. Okay. So it's a simulator. Now, if it's a simulator and is it running on the cloud?
Yes.
Okay. And if their software is not up to date with operating systems, could that actually be a problem in communications? And why
I
we
would
have so many
assume.
issues with this laboratory program?
I would assume, yes, if they
Okay,
have, if theirs is not in conjunction with yours. And there's typically a lag with Mac where it's, you know, when Windows updates, because the fact that 85–90% of the people operate off Windows, they tend to update those things quicker. Mac tends to be a little bit of a lag.
Thank you, Haley.
Mm-hmm. Because there aren't as many of us, we get neglected on a regular basis.
Of course we do.
Just saying. So.
Okay, Kelly. I'm with you, bro.
All right. Software as a service company would be using all third-party systems. The data is out there. It's not running the company's own clients, or they have no ownership of it. So your data would be more at risk with for something like software as a service. So you would use it. I mean, would it be okay to use it for things like email and stuff like that? Yeah. You know, it'd be okay. But if you're going to be emailing a lot of proprietary information, research and development, all that kind of fun stuff, you know, especially like if you're in, say, let's go with pharmaceuticals, and you're dealing with, formulas and stuff like that, your entire business model goes around, it might be worth it just to set up your own email servers rather than rely on somebody else's. So it's kind of one of those convenience, security. We're getting a lot of convenience using software as a service. It may not be a perfect fit, but it's relatively inexpensive and it's ready to go versus, protecting our interests as a company and making sure we're going to be here in 3 years, so we have to make these trade-offs and determine what our quote unquote risk appetite is with regards to our data. What kind of risk are we willing to accept in order for the convenience that we need to operate? And it's time to climb. Go ahead and pause. All right. Questions, comments, concerns? All right. So some security risks in the cloud that we have to worry about. First one being session writing is essentially when a hacker has essentially picked up on the cookie that has been given to you by the server and now uses that tracking piece of code as a key to essentially mimic who you are to gain access to the system. So they're taking essentially ownership of what was your session and now gaining access to the system that way. So it's called session writing. So it's when they steal the cookies from your computer, use it as their authentication method to get in. For those of you who didn't know what cookies were, that's little pieces of code used to track your computer, where it goes, what you look at, where you've seen. If you ever wondered why, when you go to one website, like you go to Walmart and you look at a t-shirt and then you go and every website you visit for the next 5 months shows you variations of that t-shirt for advertising, you can thank cookies for that. Yes, Leela.
So do you clear your cookies often?
Yes.
Okay. Just want to know.
Absolutely.
Are you asking Kelly if he eats cookies often?
Daily,
that supposed to mean?
Especially this time of year. It was a great meme I saw yesterday. It was like, it showed like Kermit looking out the window drinking tea. It said, "Don't lie, you were big in August."
Oh, I have another question. So I'm not sure if sites do this or not, but if I visit a site and it asks me to accept cookies, I normally say no.
Okay.
Do you know if they do it anyways? Like
typically they shouldn't if they have prompted the request and you've stated no, because typically what will happen is if you're not allowed to view their site without the cookies, they basically just say you can't proceed unless you accept our cookies.
Mm-hmm.
Because basically what that's saying is that you're kind of allowing them to track you to a degree.
Okay. Thank you.
Mm-hmm. Now, would I put it beyond nefarious websites to put that code in there anyway? Like legitimate ones? No. Less scrupulous ones? Yeah, they might still do that. But that's, unfortunately the nature of the beast when you're dealing with bad actors. Yes, Jessica.
So sometimes when you go on a site and it does make mention of the cookies, it basically like it's a low-key threat of, oh, you won't be able to see everything properly unless you accept these cookies. Where I'm like, well, I gotta accept because I want to see everything. So if you don't accept the cookies, is that going to hinder you from viewing and accessing the information you typically went there for?
It depends on the
website. Keep things away from you because you didn't.
Depends on the website. Depends on the website. Some won't. They're just like, hey, it's so that we can better advertise to you. And others are kind of like, well, if you don't accept it, we're not letting you see our stuff. So, yeah. I mean, it depends. And some are just like, yeah, well, we tried, and they'll just let you in anyway. So it all depends on the website itself, whether or not they're going to be strict about you accepting the cookies in order to be able to, view their services, or whether they're just kind of like, yeah, we would like you to.
Okay, thanks.
Oh, no problem. Yeah, Cynthia.
So when this session rating thing, when does this happen on the layer?
When does what happen on the layer?
The session, right? Meaning, like, when you have, like, if you're a hacker, and does this happen like on the session layer of the seventh? I know we haven't talked about it, but I kind of want to put it out there. I know there's like 7 layers, and I think
And we talked about that was yesterday.
probably we didn't go into depth about it.
Well, no, when you're not. Well, we went about it in as much depth as you're going to need for A+.
Right, but I'm saying for like the 7th layer, like, does this happen like on the session layer?
Yeah, I would say presentation or session would be where this would happen.
Okay, all right. Kind of sort of when I want to understand it as I go along.
Gotcha. There was a third hand up. Did I miss somebody? Or did I accidentally answer a question? I like when I do that.
Can I have one? Small one.
I swear he's a little hobbit. All right. So next, we have VM escape, or virtual machine escape. We briefly talked about this in the last session. This is where you have set up and established virtual machines, and an attacker can take advantage of remotely using a vulnerability through the hypervisor itself. The remotely controlled machine can escape from the sandbox environment, gaining access to all the VMs on the machine as well as the operating systems. So VM escape, pretty straightforward. It is what it says it is. Essentially, an infection happens within a singular virtual machine, and they are able to break out of it and get into the other virtual machines on the hypervisor. And then you have reliability and data protection. So cloud service, you are expected to have certain levels of availability. And if you get into network and security, they start talking about the amount of uptime that is required. And it's like 99.9. And then for each 9 you add, costs goes up exponentially for this higher level of uptime that you want. Like 99.9 would still allow for like a week's worth of downtime in a year. That's a lot of time in with regards to business. So some people want 99.99, which would only allow for like an hour of downtime a year, and you're talking big money to guarantee 99.99% uptime versus 99.9% uptime. Now, as with any company you are going to be doing business with, you need to do your research. Make sure they're reputable. Make sure they have, they're in good standing with their current customers. Do they have a disaster recovery plan or a backup plan should, their data center go down? Do they have more than one data center? There are redundancies built in to protect your business in case something happens to their equipment. What happens if a server there gets fried? Do they maintain backups of your data as a just in case, even though you should have it yourself? If they have it on site, it allows for the servers to be cycled up much faster. So you always want to make sure about reliability and data protection. Now, it's not all sunshine and rainbows on the cloud. Sometimes they can be used for unscrupulous purposes. So they can be used for denial of service attacks, because basically the cloud provider is just providing you, especially if it's infrastructure or something like that, they're providing you with resources. Hackers and stuff can actually utilize these resources to perform attacks. Now, when dealing with your providers, always make sure they're using the best encryption standards, the most secure communication channels, as well as using secure APIs. Will help keep your data safe. Again, we will dive into some of the stuff even more when we get into security. We're more looking at this from a definitional standpoint at this point. Questions so far? All right. Told you we'd have 2 short sessions today. Now, we should be able to compare and contrast the different types. Wait a minute. Who put this one in here? The different types of clouds. Somebody threw the printer one in there. That's awesome.
Kelly, I'm already trying not to lose my mind. When I saw that, I was like, what just happened? Did I transport in time?
We all
I'm
lost
sorry,
about
guys.
24
I
hours.
just
You
lost
guys
it, like-
slipped through the matrix. We lost about 24 hours worth of time. We're going to have our full mocks tomorrow. I hope you enjoyed our presentation on printers. Mark did a wonderful job. So we should know the different types of cloud services, where we have our infrastructure as a service, our platform as a service, our software as a service, the various differences between these, the various cloud makeups we have, where we have public, private, hybrid, and community. We should also remember rapid elasticity, on demand, metered billing, all that kind of fun stuff. So pay no attention to the last slide. We'll do the Wizard of Oz thing. Don't look at the guy behind the curtain. And that is our session on cloud computing. Any questions, comments, concerns? Other than the fact that the last slide completely had nothing to do with everything that came before it. That is a concern, yes.